Hi everyone, welcome to G World of Academic Physics. Today we will discuss the very fundamental of electrostatic, that is electric flux. The electric flux, it is written with the symbol phi. If I'll think about this electric flux, I will consider an area. This is my area. Suppose my area is looking like this. This is a sheet you can consider. The area of this sheet is A. I will treat the area as a vector quantity, and the direction of the area vector is always perpendicular to the plane. If I will consider this is my area of the sheet and it is always perpendicular to the plane, so I will consider the direction is like this. And what is that? The electric field lines have been moving like this. These are my electric field lines, and how much angle it is subtended with the area vector? It subtended an angle theta. This is my area vector and this is my electric field vector. The definition of the electric flux says it is the dot product of electric field vector and the area vector. If you carefully observe, A dot V can be written as A cos theta. So a student can think like this: A cos theta, or this is can be written as E cos theta. So if you observe very carefully, if I will treat A as a vector, very carefully observe these things, A as a vector, how many components of A? This is one component, this is A cos theta, and there will be another component of A which is nothing but A sin theta. So can someone make a statement that this is nothing but E and A parallel component of area vector, and this is nothing but electric field parallel component? And what is the definition of electric fluxes? Student usually write the dot product of electric field and the area vector, or it can also be defined as the component of A which is along the direction of E. The component of a student have two options. He can break the component of area vector or can break the component of electric field. If the first case, I will break the component of area vector, A cos theta, A sin theta. If you observe very carefully, this component of A cos theta is along the direction of electric field. So one can make the statement also, the component of A along the direction of electric field. Similar fashion, one can make the expression that the component of E along the direction of A. If a student will break the component of E, this is theta, so this is E cos theta and this is E sin theta. So in this case, the component of E which is along the direction of A. So one student can write the definition of the flux as it is the product of electric field, dot product of electric field and the area vector, or the component of E along the direction of A, the component of E along the direction of A, or the component of A along the direction of E. These are the two definitions of the flux one can write. Some cases, if the area, in this case the area is easily calculated, if the surface is a random surface, in that case what we will consider, suppose if it is a sphere like scenario, in that case if I will go for, or any random surfaces, it will be like this. If I will go for, and it is in a uniform electric field like this, or it is in a uniform electric field like this, in that scenario, how much flux is passing through this? We will consider, we already treated area as a vector quantity. So in that case, we will think about an elementary area. So we don't know about the proper information about the symmetrical area, so we'll consider an elementary area dA, and this is my electric field. So what is the definition? So for the elementary area, I'll write my elementary flux, that is nothing but E dot dA. If I'll go for the total flux, I will use the simple mathematics concept. I will do the integrations. So it is very clear for the student perspective that one student, if you have the proper information regarding the area, one can suddenly go for this. If you have, the surface is not clear, so you have no information regarding the surface, any random things have been given to us, then we'll go for an elementary sections. And elementary sections will consider an elementary area. So how much electric field passes through this elementary area, that is nothing but the elementary flux, and integrating all these elementary flux we will get the information of the total flux. I hope the scenario is pretty clear. And second most important thing, dot product always give the scalar. So flux is a scalar quantity, flux is a scalar quantity because it's the dot product of the two vectors, and unit is nothing but volt into meter. This a student has to be remembered. What is the unit of electric flux? Volt into meter, and have to be remembered. These are the basic things one student has to be remembered. The second most important point that one has to remember, if a charge is enclosed within a closed surface, this is a point charge. So point charge, there will be some electric fields, because if a positive charge is here, each and every time the electric field lines will be radially outwards. So what will happen, a point charge is here and it is enclosed within a closed surface, so definitely the field lines will passes like this from this charge, and it is radially outward. So how much flux passes through this closed surface, how much flux passes through this closed surface, the expression is Q upon epsilon naught. This is a very fundamental thing the student has to remember. If any charge is enclosed within a closed surface, the flux that can be coming out this closed surface is Q upon epsilon naught. This is a very basic law of Gauss law. You can later we will prove these things. So student, if you remember these things, it will be more useful. Third most important things, these kind of questions are now very common in competitive point of view. Suppose a charge is Q is here, and this is a disk. This is my disk, whose radius of the disk is r, and it is at a distance. I'll say this distance is suppose d. The question will frame you how much flux passes through this disk. How much flux passes through this disk? It is very clear that if a point charge, so everywhere the field lines will be go like this, radially it will be outward. So whatever the flux will passes through this region, so that much of flux will passes out of this disk. The field lines that passes through a area. So how much flux will passes through due to this point charge Q if it is placed at a distance d from a disk, non-conducting disk. I preferred which this non-conducting disk. There are two certain approaches for this question. These are very fundamental questions. Disk, an element, disk, if you consider a disk, the element is ring. So I will consider an elementary ring, because so many elementary rings if you combine, it will give you a disk. And this elementary ring radius is r and thickness is dr. And a Q charge is exactly at a distance d. Due to point charge, the field line will be go like this, and area vector always plane perpendicular to the plane, so area vector will be like this. This is an elementary ring, so I will write my elementary area. This is my electric field. If this angle is theta, this angle also is theta. So what is my flux? Because I am writing for the elementary area, so I will write my elementary flux. The d phi is nothing but E dot dA. What is the angle between E dA? That is E dA cos theta. This is my d phi. If I will find for the total, this is an elementary flux. If I will go for total flux, I will simply integrate this E dA cos theta. This is a point charge. And how much distance this point charge? This is d, this is r. So this is d square plus r square root over. So definitely due to this point charge, the expression of electric field is nothing but kq upon r square, and this is nothing but d square plus r square. Square up square, it will give you only these things, which I am writing like this. And what is the elementary area? Elementary area is nothing but perimeter into thickness. Perimeter is what? 2 pi r, and this thickness is what? dr. And what is that? Cos theta is here. Cos theta, if I will write my cos theta, what is the theta expressions? That is d upon d square plus r square root over. I hope the scenario is pretty clear. And if you observe very carefully here, the variable is dr. If I will add up all dr, this is dr, again dr here, again dr here, it is very usually this dr can varies from 0 to r. A student has to be visualized very clearly that this is my dr. If my circle is here, the dr is this thing. If little larger circle, the dr is like this. Little larger, it will be extended from minimum 0 to maximum r. So what are the expressions? You can think about it. This is 2 pi k q outside, d outside. This is nothing but r dr upon d square plus r square whole to the power 3 by 2, and this is 0 to r. And if you solve this integration, I am leaving this integration to the viewers, those who have been watching here. If you solve these integrations, what is the result will be come out? Let me see what is the result that will be come out. The result will be come out like this. This is 2 pi k q d. This is, if you solve these integrations, it will be like this. R square plus d square. This is small r square, little carefully. This is small r square because we are writing cos theta for the element. This is small r square, and this is small r square d square, and we will put the limit 0 to r. This integration is very easy. One can assume this d square plus r square as t square, and if you solve these things, you will get this kind of integration result. Without wasting much more time, a student has to think about its own. So 2 pi k q d, and what is that? If I will put my limits, this is nothing but what? 1 by d square. This is root over. This result will become in term of root over. So this is d minus, and this is what? R upon, and this is 1 upon r square plus d square root over. I hope this scenario is pretty clear to everyone. Now, little carefully I will multiply all these things. So this is 2 pi k q, and this is d is simply multiply here. The expression will be in term of root over. So d, this is 1 minus d by r square plus d square root over. I hope this scenario is pretty clear. K can be written as what? K can be written as 1 by 4 pi epsilon naught. So simply I will substitute 1 by 4 pi epsilon naught. This is the value of k. This is 1 by 4 pi epsilon naught into 2 pi q, 1 minus d upon r square plus d square root over. The expression will become as q upon 2 epsilon naught 1 minus this d upon r square plus d square also can be written as what? This is d, this is r, and this angle we have assumed it theta. So this d upon this is d square plus r square is nothing but what? Cos theta. So it is very common, a student has to remember logically that if a charge is at a distance d, how much flux passes through the disk? The expression is what? Q by 2 epsilon naught 1 minus cos theta. This is the expression one has to be remembered. So for the student perspective, I want to make it to be conclusive way to everyone that if it is a disk of radius r and there will be a point charge at a distance, some distance d, so how much flux will passes through this disk? The expressions of this flux is phi is nothing but q upon 2 epsilon naught 1 minus cos theta, and theta is which angle? This angle is theta. So one can write also like 2 epsilon naught 1 minus d upon d square plus r square root over. This is my final conclusion. I want to, for the student perspective, those are preparing for the competitive, they must remember these things. This is one way to solve this question, little lengthy these questions. This can be solved through another method of solid angle. Those who have studied this solid angle, they can easily think about it. If this is a sphere, if a charge q is at a center, for any point inside the sphere, for a complete sphere, the solid angle is 4 pi. The solid angle is how much? 4 pi. This is a very fundamental thing. Solid angle is what angle? If you consider a cone, the angle, this angle is treated as what? Solid angle. For a complete sphere, the angle is 4 pi. So if a charge is enclosed within a closed surface, how much flux? The flux is q by epsilon, that is the basic Gauss losses. So 4 pi solid angle, the flux is q epsilon naught. Flux will be passes through this. And for one solid angle, the flux will be q by 4 pi epsilon naught. And I said this much of solid angle, this solid angle, that is solid angle expression is nothing but 2 pi 1 minus cos theta. This is the expression of the solid angle. Those who have studied, that is useful for them. For one solid angle is like this. For this solid angle, you can easily multiply 4 pi epsilon naught into 2 pi 1 minus cos theta. So this is the directly one can find the expression of 1 minus cos theta. A student must know the relation between the solid angle and the plane angle. Then this question can easily solve. 4 pi solid angle, the flux can be passes as q by epsilon naught. One solid angle, how much flux will pass? In this solid angle, how much flux will be passed? One can directly find these expressions. Those who have good knowledge for solid angle, they can think about this. I hope the scenario is pretty clear. So I'll suggest to the student to remember this formula. When a charge q is placed at a distance d to a non-conducting disk, how much flux can be passes through the disk? That phi equals to q by 2 epsilon naught 1 minus cos theta. If the same scenario, a question will be framed like this. This is a disk whose radius is r. At a distance d, there will be two charges, plus q, and this is minus q. I have placed like this, and distance is this distance also d, and this distance also d. The question will ask you how much flux can passes through this disk. This is a very common application based questions based on these fundamentals. If you look at this charge, I already said flux is a scalar quantity. Look at these things. Due to this, what is the direction of the flux? How much flux will be passes like this? Due to this charge, one charge, I am considering as 1, I am considering this is as 2. So due to flux, the expression is q by 2 epsilon naught 1 minus cos theta. Theta is this angle. And this is, I already said, this is which charge? Negative charge. This is which charge? This can be a negative charge. I am writing here for the better visualizations. For the negative charge, field lines are coming radially inwards. This is positive, radially outward. So the flux will be like this. The total flux will be passes like this. And also negative charge, the flux also like this. So two flux will be added. So the same expression is nothing but what? 1 minus cos theta. So the total flux is nothing but what? Phi 1 plus phi 2. These two flux will be added. The expression will become q by epsilon naught 1 minus cos theta. And this is q by epsilon naught 1 minus cos theta value I can simply substitute. This is d upon d square plus r square root over. This is a very fundamental things a student has to think about it. Suppose in the same questions, this is a disk and this is positive charge at a distance d, radius of the disk is r, and this is d, this is a positive charge and this is also a positive charge. Then the net flux question can be asked you how much flux can be passes through this. Due to positive charge, the fields will be like this, and due to this charge, the fields will be like this. So if a student will be think about it, phi 1 value is what? Q by 2 epsilon naught 1 minus cos theta. phi 2 value also what? Q by 2 epsilon naught 1 minus cos theta. But the net flux is 0. Net is what? 0. This student has to be think about it why it is 0, because for this how much flux can passes through this will be like this, and for this charge the flux will be passes like this, because positive charges the field lines are radially outwards. This is outward in this direction, this is outward this direction, so the net flux is coming to 0. This is one information the student has to be in your mind in order to think about this kind of flux questions. If you will think about one more question based on this point charge, suppose this is my cylinder. This is my cylinder, I will say. Exactly on the axis of the cylinder, mid axis, you can say, mid of the axis, one charge Q is located, and I will say the radius is R, and total duri I will consider this is as D, and this duri also as D. This is the radius R. The question will be ask you how much flux passes through the curved surfaces. The question will ask you how much flux passes through the curved surface, how much flux will be coming out of this curved surfaces. If you observe very carefully, the cylinder having two surfaces, one is flat surface, this is the flat surface, and this is the curved surface. So the net flux is nothing but combination of two surfaces. One is flat surface and this is what? One is curved surface. We know if a charge is enclosed within a closed surface, the total flux is nothing but Q by epsilon naught. And due to flat surfaces, and this is like a disc, this is the flat surface. So this is my flat surface and this is what? My curved surface. So what is flux through the curved surface? Is nothing but Q by epsilon naught minus flux due to flat surface. I hope the scenario is pretty clear to everyone. If we will go for this net flux, I will use the concept of if a charge is enclosed within a closed surface, flux, net flux answer is like this. Question is asking how much flux passes through the curved surface. So total flux is nothing but the net flux. Net flux is Q by epsilon naught, and we will find for this flat surface. And I already know flat surfaces, this is kind of disc and this is also kind of disc. How many discs? 2 discs. So what is the expression? This is by Q by 2 epsilon naught 1 minus cos theta due to one disc. How many discs? 2 discs have been there. So I will simply multiply Q by epsilon naught minus Q by epsilon naught 1 minus cos theta. So how much answer is coming? This is Q by epsilon naught. This is Q epsilon naught 1. This is Q epsilon naught cos theta. This is the expression is coming. And this is Q by epsilon naught. Cos theta value is what? D upon R square plus D square root over. I hope this is my final answer. A student has to think about it. These are some basic application of the flux. If this kind of scenario is asking like you, how much flux passes through the curved surface, one can think about the net flux is sum of the flux through the flat surface plus curved surface, and the flat and curved scenarios one can think about like this. I hope the scenario is pretty clear to everyone.